Someone on the Discord server asked me about YOLOv3 versus Darknet YOLO. So I got everything installed, trained some networks, and in this video I'll review the results. On the first screen you'll see 4 videos, but I'm actually comparing 3 different versions. Version 10, version 3, and version 4. When training YOLOv4, my training time was 115 seconds, just under 2 minutes. So I wanted to see what YOLOv10 looks like when training for the exact same length of time. The YOLOv10N results weren't great. It could only detect 2 of the 5 objects, so I retrained YOLOv10 for 1,000 epochs instead. Lastly, I decided to use Darknet to also train one YOLOv3 Tiny to see what it would look like with the same dataset. Let's pause this video and put some text on the screen to highlight a few important things. YOLOv10N at 104 epochs is in the upper left corner. It took under 2 minutes to train. It fails to detect 3 of the 5 objects. It takes about 5.4 milliseconds per frame to predict. The entire video took 13.79 seconds to process. YOLOv10N at 1000 epochs is in the upper right corner. It took over 16 minutes to train. It takes about 5.3 milliseconds per frame to predict. The entire video took 14.15 seconds to process. Darknet YOLOv3 Tiny at 3000 iterations is in the lower left corner. It took 3.5 minutes to train. It takes less than 1 millisecond per frame to predict. The entire video took 3.36 seconds to process. Darknet YOLOv4 Tiny at 3000 iterations is in the lower right corner. It took under 2 minutes to train. It takes about 1.1 milliseconds per frame to predict. The entire video took 3.5 seconds to process. So let's quit from this 4-panel video and I'll bring up a side-by-side comparison of YOLOv10N and YOLOv4 Tiny. After the time it takes to train, the first obvious difference is the time it takes to process each frame. Inference with Ultralytics YOLOv10 is nearly 5 times slower than with Darknet YOLOv4. The next difference is the confidence levels for each object found. In this video, you can see how YOLOv4 Tiny returns nearly 100% confidence, while YOLOv10N returns lower values and in some cases fails to detect objects or incorrectly identifies duplicates. The YOLOv3 Tiny and YOLOv4 Tiny networks trained for this video were both sized at 224 by 160. I have another video where I explain why I chose those sizes. I will link to that video from the description below. I don't know what size YOLOv10N uses by default, but the original videos used both to train and to run inference all measure 640 by 480, which I'm guessing should be handled easily by any YOLO framework. A link to the dataset I used will be in the video description. I'm confident that Darknet YOLO still outperforms other YOLO frameworks in training time, inference time, and when it comes to the quality of the output. I'm very happy with all the optimizations that have gone into Darknet YOLO since the Hank AI fork was created a year ago. Especially when combined with DarkHelp and DarkMark, I believe that the Dark suite of YOLO applications is still the best option for people wanting to do object detection with a completely free and open source YOLO framework. Please join the Darknet YOLO Discord server if you need assistance with Darknet, DarkHelp, or DarkMark. I will leave a link in the video description below.